Okay, good morning, year 8. I'm just going to do a quick check to see if this is recording okay. Yeah, which it is. So, good morning. This is sort of session number 1 of remote learning. So what's going to happen is, hopefully it's going to be very similar to a normal lesson for you. You're going to watch this video. The only difference is you're obviously going to see my face in a slightly different way. So I want you to make notes like you would in your normal exercise book, margins, underline titles, set out your work really nice and neat. Now, it may happen over time that you run out of space in your exercise book. So if this does happen, what I want you to do is you can either get a new maths book, your parents might be able to order one in, or working on paper is okay. And then when we come back, you can sort of group it all together and we can put it in your folder and keep it nice and safe. Okay, so this is going to work like a normal lesson. I'm going to come off, my face is going to come off the screen in a minute, but my voice will still be live, and you can make notes as we go. Please do pause the video if you need a bit of time to draw any sketches or just to slow up, and we'll go from there. Now, most questions will be set through Hegarty, and sometimes I'll be asking you to scan work in and then send it so I can check your workings. Other times you'll just need to complete the tasks. Now today's lesson you just need to complete the tasks, but I do want you to show working in your book because I will be checking it when we come back, but you don't need to scan it in today. Also homework today, it is on Show My Homework, but all you need to do is complete the Hegarty tasks. Okay, you need to complete the Hegarty tasks. I will be on email as well, so do email me if you've got any questions, and hopefully this works well. I think we'll do really well if you sort of engage with the process, and there's no reason why we can't just carry on as normal. Right, okay, I'm going to come off screen now, off the screen, but you'll still be hearing my voice. Okay. Right, okay guys, so let's draw a nice margin in, and can you put the date? I think is the 23rd, if this works. Sorry, the 20. Just change that back to black. So it's the 23rd of March, 2020, and today's lesson is going to be volumes of prisms. Okay, volumes of prisms. Right, okay, now a prism is a three-dimensional shape that has a consistent cross-sectional area passing through it. So it could be something like this. As long as the shape is the same wherever you make a cut, that's considered a prism. So this area here is the same all the way through the shape. Now, I think it's a good idea to draw this one out as an example in your books. You could also have a cuboid. In fact, you could have any shape here that's the same cross-section all the way through the shape. Right, now the formula for the volume of a prism, is equal to the cross-sectional area. Now I'm going to call that the CSA for short, okay, so times the depth. Sometimes that's the height, times the depth. So this is the depth there, and the shaded area on both of these shapes would be the cross-sectional area. Okay? Right, now I'm going to do a couple of examples finding the volume. So EG1. I'm going to do, I've got a shape here, and the area of this, let's say the area of this is 8 meters squared, and the depth is 7 meters. The question would be, find the volume. Please write this example in your book so you've got it as your record. So find the volume. So you might want to pause it, have a go yourself. But how we would answer this, we just follow this simple process. The volume is equal to the CSA times the depth. So that in this case, the volume, the CSA is equal to 8, and the depth or length is equal to 7. So it is 56 meters squared. And that's the answer there for EG2. Now you may need to EG2, you may need to work out the CSA first sometimes. So what I'm going to do is I'm actually going to take a, I'm going to take a cuboid. So I'm going to take a cuboid. And I'm going to call that maybe 6, maybe 4. Let's put these in meters and maybe call the depth 3 meters there. Right, so again, find the question, find the volume. And the answer to this would be, again, volume equals CSA times the depth. Now in this case, the CSA is going to be that shaded area there. So CSA, and it's a rectangle, so it's 4 times 6, which is 24 meters squared. Again, please do stop the video if you need to, that's fine. So my final answer, the volume is going to be equal to this, is 24 CSA times the depth, which is 3, which is, what's that, 72 meters cubed. Okay, let's just do a quick check, make sure I've got that right. 12, and then carry on, 72, yeah, 72, that's good. Right, the final example is going to be a sort of a slightly harder shape. It could, CSA could be any shape, really. Cuboid's probably the easiest, but we might even have a trapezium. So we might even have a prism that is a trapezium. It could be any shape. So and we might have a trapezium like this. Let's say the height of the trapezium is, say, 4 meters, and the depth is maybe, no, that length is maybe 6 meters, and let's make this one 2 meters, and then the depth of the whole shape is, say, 5 meters. And I think when you're sketching these out, try and do it, I would try and practice your freehand sketching here, because it's a really useful skill to be able to do. Right, same question again, find the volume. Now, give yourself a bit of time and have a go yourself. But, so you might want to pause the video, or I'm gonna carry on for you. Now, the CSA this time is a trapezium. Now, you might have to look back in your notes, but the formula for the volume of a trapezium is half the sum of the parallel sides, times the distance between them. Okay, times this is very, and in this case it's half the sum of the parallel sides. Well, these two are the parallel sides, that side and that side. So it's 2 plus 6, not 8, sorry. 2 plus 6 times the distance between them, which is 4. So it's half times 8 times 4, which turns out to be 16 meters squared. Yeah. So therefore, the volume, remember 3 dots means therefore, the volume equals 16 times the depth, which is 5. So 16 times 5 is 80 meters cubed, and that would be your answer. Okay, so you've got 3 examples there to have a look at. Please do make that nice and neat in your books and copy that out nice and neat. I do appreciate there's quite a lot of notes today. It won't always be like that. Once you've copied out the notes, oh, sorry, let's go back on here. You can put a subtitle of Hegarty, and I've set you some Hegarty. Questions to do, some tasks to do, and your classwork and homework today is to finish those tasks. Now, you do not need to draw out every shape for these. Okay, you do not need to draw out every shape because you've got the examples set for you. But if you want to do that, you can. Right, good luck on that. I am on the email if you've got any questions, and I'll try and help you the best I can. But do remember the Hegarty videos are also there to help you. And good luck this week and going forward. Speak soon. See you on Wednesday.